I'm the head of the group on smart city and infrastructure, and I'm very glad to welcome you here to this session today about the future of asset management using AI. So the idea of this session is 45 minutes. We will investigate together how AI and machine learning can help utilities for planning asset management strategies. So we will investigate issues such as how can we better plan investment needs for the future? How can we target the investment for sewer rehabilitation today? And how AI and machine learning can help us to find priorities of rehabilitation in the network. So the structure of the session is very simple. We will have two presentations by two speakers, Nick Lengemann from Berliner Wasserbetriebe, so the Berlin water utility, and Aisha Mamade from Baseform in Portugal. Each presentation will be 15 minutes. After each presentation, we have 5-minute question. And at the end, we still have 5 minutes altogether questions if there are more questions for one or for the other. And I would like to invite on our digital floor, Nick Lengemann. So Nick Lengemann is working at Berliner Wasserbetriebe, as I said, the utility in Berlin for drinking water and wastewater management. He's working there since 2012. He has a Bachelor of Engineering in Construction and a Master of Science in Business Engineering. And since 2016, he's in charge of asset management for the sewer network, and more precisely of long-term investment forecasts. So he has been, over the last 5-6 years, co-developing the SEMAplus solutions, starting with research project called SEMA Berlin. And he will give us a grasp of these projects today and present us the SEMAplus solution. So thank you, Nick, for joining us, and the floor is yours for the next 15 minutes.
Okay. I hope everybody can hear and see me. And thank you, Nico, for your introduction. So welcome to everybody. My presentation in the next 15 minutes relating to the topic, the role of machine learning in sewer rehabilitation planning in Berlin. I will show you some insights of our asset management tools for sewer deterioration called SEMAplus. And today I represent the project results in representation for my colleagues from Berliner Wasserbetriebe and Kompetenzzentrum Wasser Berlin. So I turn to the next page, yes. Where does our need for those asset management tools come from? It's important because to manage our assets at Berliner Wasserbetriebe, we've got several questions which we as an asset owner should be able to answer. This question can be divided in strategic and operative issues and challenges. So the strategic questions, for example, how will our sewer network condition evolve in the future, or which type of investments are needed to secure network operation? What is the maximum target condition that can be reached with current resources? So this on the strategic side, and on the operative side, maybe what is the real condition of our pipes today? Where is the greatest risk of failure? Or where should we inspect and rehabilitate in priority? So with our developed tools, we are able to answer these questions. But before I step inside of the tools, I give you a short clip, an underground view of our topic, and I hope the video will play. Yes. So the sewer pipes in not only in Berlin, all over the world, are mostly in the underground and hidden from our human eye. Because of that, it's difficult for an inspection of the current condition without special equipment. So the CCTV inspection, as state of the art, enable us to assess our sewer condition. Here in this video, the condition developed from green to red, so from good to worst. And now you can see, without any rehabilitation program, the future condition of our sewer network will not be able to fulfill the task. So we need a rehabilitation strategy for our sewer network, but we need those tools to get the perfect or the best strategy. And now, sorry, next slide. I will go on and show you some insights of the two simulation tools we developed. First, the strategy simulator. It forecasts the long-term development of the complete sewer network condition over several decades. And the second, the pipe simulator, it predicts the current condition of individual sewer pipes and helps to localize urgent rehabilitation needs, called as hotspots. So the first strategy simulator, this tool uses 11 cohorts calibrated with GOMPITs and partially with assumptions. For example, on this slide, there are three cohorts, clay, concrete, and brick, and you can see the deterioration over the years and the probability and percentage of each condition, 1 to 4. And on this, at this moment, I will left the demonstration, the presentation, and give you a short demonstration live how the tool is working, so you can better understand what we are doing and how we can get the benefit out of the tool. So, I did some preparation, so it is faster in this presentation, in this live presentation. So you can see the online web application strategy simulator. You have different stages. The first stages is where you can make your input. So not even in Berlin. So every sewer network can be uploaded with the network data here. And in the second step, you can put your rehabilitation strategy parameters. So about the years, about the performance, and the different rehabilitation, like renovating or the classical rehabilitation. And if you all have done these pre-settings, you can simulate your strategy and get a result. And the result, I've already done this, so it's a little bit quicker. You've got here in different charts. You had a chart, have a chart about the performance, about the condition, about the cost, age, or substance, and then you have a nice portfolio about your rehabilitation strategy. And in the next step, if you have various opportunities to create a rehabilitation strategy, you can simulate, and then in the next step you can compare. And this is the next stage where you can compare different scenarios. So example 1, example 2, and then you can with this comparison make the best decision for your company or for your sewer network, and can argue against your management or your government why you need those budget to make your sewer network in a good condition. So let me get back to the presentation. And this is also important even for us, that we can convince our management or the government, because we wanted to implement the strategy simulator, and therefore we needed a proven accuracy. This was necessary for us and for our management, and therefore we used our sewers as not inspected. So they are we take them as not inspected and simulated the aging to the current inspected status. So it was helpful to have some inspections where we can simulate to, and then we can check the accuracy on network level. And here on this slide, you can see the different charts. The difference between inspection and prediction, the model outcome, is at all, and in the age area 51 to 75, where the most sewer were replaced, is almost non-existent. It's below 1%, and this was the our result of from the project SEMA Berlin, and was the base for our implementation in a regular process at Berliner Wasserbetriebe. So I've got not much time, so I jump to the pipe simulator. The pipe simulator is helpful for the operative asset management. Then we can is for the prioritization of our pipes with a high risk of failure. So we can make a targeted CCTV inspection and rehabilitation, and we use a machine learning model random forest. And this model use several variables relating to sewer characteristics and environmental factors, so like material diameter, soil, groundwater, trees, or the location. And the model random forest uses decision trees, and each branch is a prediction. So the model twice related to the settings, the best allocation. So about the branches, maybe age, material, or the depth. And so every branch is a prediction, and it's used for short-term and individual condition simulation. So I give you therefore also a short demonstration how the simulator works. So it's also an online web application where you can put your network data, inspection data, and as a result, when you simulate, you've in step one, you've got a list from all pipes in your sewer network, ranked if the risk of failure is higher, so the pipe is on in the rank number 1, and if you are going below to the other ranks, the risk goes down. So you can take the list and put the list or merge the list with your inspection program, and can find hotspots where you have to prioritize your inspections. So the rehabilitation process doesn't need so much time. You don't waste your inspections of pipes which are in a good condition. You can take your time, can take your inspection and put them in the street and find the pipes with worst condition. And in this simulator, you have got the list, and here also a map of here Berlin with different areas and with different colors related to their risk of failure. So these two simulators are implemented by the Berliner Wasserbetriebe and are helping us in our daily business. But also with the pipe simulator, we had the requirement that we evaluate the accuracy. And you can see here a chart, and take a look especially at the first bar, where we can have a closer look at the detection rate. So inspected condition versus the simulation. In this chart, here are 0 pipes in poor condition already inspected. So in this case, the success rate to identify new pipes in poor structural conditions over 57%. Another example, when you have got more pipes already inspected in poor condition, like in our example 60%, the success rate to identify new pipes in poor structural condition goes down under 48%. And in another chart, you see the success rate depending on previous knowledge. So what we have seen before, that if you have more inspected pipes in a bad or worse condition, the success rate goes down for new pipes. So it's a more benefit for sewer networks with no inspected pipes than a sewer network with inspected pipes. But in Berlin, we have our complete sewer network already inspected. So it's the benefit, it's not much as high if we are not. But when we do our inspection program, in the past, it was all over the city. And now we can concentrate to the hotspots and don't waste our time to find pipes in good condition. So yeah, in conclusion, our benefits for the Berliner Wasserbetriebe on these two levels, network level and pipe level. First, the network level, the strategy simulator. Now we have a valid forecast of the condition development of the 10,000 kilometers sewer network in Berlin. Like I show you with a comparison in the strategy simulator, we can optimize our strategies. So with our scenarios, our investment planning every year, we have a data-driven validation. We can better argument our investments in front of the government. And with these results, we can improve our communication with other utility departments. On the pipe level, we have an accurate prediction of our current condition of the sewer pipes, but also up to 10 years. And very important, this identification of our rehabilitation needs, these hotspots. And like I said, our inspection strategy changed with implementation of the pipe simulator from the inspection strategy all over Berlin to a risk-based inspection strategy. And also, if we know these hotspots, we can go to the decision-making process with other municipal services to get maybe a combination of our construction and so get a better flow of our in the city of Berlin. So it's both simulators have a great benefit for the Berliner Wasserbetriebe. And before I end my presentation, I just want to give a short call. Maybe you want to join the SEMAplus community. So our community of users from the SEMAplus tools, we have regular meetings. We are cooperate to optimize and improve our SEMAplus tools. You've got the latest updates and technical innovations. And from my side, very important, you've got a return on experience from other utilities. So you can share your experience and get a better implementation. Of course, it's very transparent. So you see the both simulators were web application, but it's not a black box. It's open source, and everyone can really easy understand what is happening inside with the simulation. But of course, before you implement such tools in your company, training program is necessary. So I hope everyone or for everyone it was understandable, and you've got the benefits from such asset management tools for simulations. Thank you. And yeah, I give back to Nico.
Thank you, Nick. Thanks a lot for your presentation. You can see all the applause coming from the audience. We don't hear, but we imagine. There is one question from Renan from Brazil about the modeling. Do you use also the type of soil or the information about the soil in the model, because it can have an influence on the sedimentation in the pipes or even different type of pressures on the pipe? Well, maybe more generally on the structural conditions. So do you consider that in the models?
Yes, in the development of the pipe simulator, we check with our in-house geological team if we can extract the different soil types and to merge with the location of the pipes. So we had checked this the combination of from soil to pipe, but in this in this process we also noticed that it's very important to know in which quality was the construction of the origin pipe. So around the pipe there is normally around the pipe there's other soil than the origin soil where in this depth, and so the quality of the bedding of the pipe is more important than in which soil depth the pipe was located.
Okay, thank you. And maybe a last question. You presented different reasons why Berliner Wasserbetriebe co-developed these solutions for asset management. In your opinion, being in charge of the investment, what do you think it's more important? Is it more to find the best strategies, or it is more to, as you say, to convince the municipalities or give the right argument to justify the investment? Was it for you the main added value of this tool at the end in your practical work?
Yeah. Even if I'm more from the financial side, from the asset management side, I would say it's more important to get to know what is necessary for the condition of the pipe. So you have to simulate your network condition, and then you know what your rehabilitation needs are. So the money or the budget you need, and you have to argue with the government, is the second step. So for us, it's necessary to know what does our sewer network needs. So our yearly rehabilitation rate, and in the second step, you take this rate of the rehabilitation, put this with the price, and then you've got your need of budget. And of course, if you have the budget you go to the government or the management, and but then you have the arguments like shown in the simulation, in the simulators, why you need those budgets to fix your long-term rehabilitation needs.
Okay, then thanks a lot, Nick. If there are more questions coming in the chat, you can answer after. Thank you very much.
Yeah. Or email. Maybe you've got some questions not yet and later, then you can write an email or message me over the Blue Planet network. No problem.
Exactly. Thanks a lot, Nick. See you later. And now I would like to invite Aisha, our next speaker, to join me on the stage. So Aisha is working at Baseform, which is a software and consulting company based in Portugal. I think that's the main headquarters.
Yes. Yes.
Yeah, Aisha is working since more than 10 years for water utilities at different positions. She work in the development of asset management plans, topic of water loss reduction, energy efficiency plans. She worked for projects in Portugal, Brazil, and in the US. She also did a PhD in civil engineering. And she's also involved since almost 10 years at the IWA, the International Water Association, being a member of the specialist group on strategic asset management. So, Aisha, we are glad to have you here, and the floor is yours for the next 15 minutes. Thank you.
Okay, perfect. Thank you, Nico. Just wanted to check if you see my screen well. Everything okay?
All good.
Okay, perfect. So thank you for the introduction, Nico. So as he said, today I'll be talking about Baseform's AI tools for asset management in wastewater systems. And I saw this picture the other day, and I think it summarizes very well the concept of converting data, which is what we get from water utilities, into some actionable results. So in this very simple image, Legos are grouped to build a house. We do the same with data from water utilities. So in Baseform, for instance, we take inspections data, namely CCTV results and their grades, and we create decision trees using AI algorithms to identify what are the potential covariates explaining sewer condition, where should the utility go next to get better results in their inspection programs, how to do proactive maintenance and rehabilitation planning. So these are some of the questions that we try to answer our customers using the inspections app on Baseform. Okay, so let me take you there. Let's go for a very specific example here. Okay, so this map that you're seeing shows the observed condition in part of a US wastewater utility serving close to 1 million population. Okay, the pipes in gray refer to pipes that have never been inspected. The pipes in green have a good observed condition, and those in red are critical. In this case, critical pipes means pipes with a grade 4 and 5. And this is defined by the user, so it could be only the 5 or 3, 4, and 5. So this is something that the user should tell the software. Okay, and in this case, over 68% of this network has already been inspected, but sometimes it's just 30% because inspections tend to be very costly, as you probably know. Okay, so these classes 1 to 5 that you see on the map, they refer, they refer to, let me go back, to a standard defect classification and scoring system. In this case, it refers to the NASCO Pipeline Assessment Certification Program, as also called as the NASCO's PACP. Okay, and in this particular case, we are talking about structural defects, but we could be talking about sags, about grease, or other types of defects. Okay, so we can put any kind of defect and then get results based on the defects that we are trying to analyze. Okay, so Baseform uses this information on the grades and then also uses the pipe features such as material, length, diameter, age. Sometimes we even correlate with other variables, could be distance to railways, distance to trees, could be related to the soil as well. And we create a map with the predicted critical pipes. Okay, this prediction is carried out using decision trees. So this map here is already colored. So every pipe on this map is color coded, as you can see. And essentially, we have used the observed inspection classes and then generated trees using a random forest algorithm to identify key variables that explain criticality in pipes. Okay. Age is usually an important factor along with material. Sometimes zone or the area or the basin is also important because it's a proxy for similar construction methods. But essentially, this map shows where shows the pipes color coded according to their criticality from the decision trees that were generated in the AI model. Okay, and one of the main advantages of this AI model is that it's very fast building. Okay, has a good performance when compared to support vector machines or other neural networks. And enables the identification of key variables and makes no assumption about the data. Okay, this means that the results that you get are literally as good as the data coming in. Okay, but this can be a problem. Okay, so this is really important because it's critical for the utilities to understand that they should be using a standard defect methodology, okay, to make sure that all the data is processed in the same way. Okay, we need a standard. This is very common. So there's a very unified standard in the US. In the Europe, not so much, and this tends to be very much from country to country. That should vary, but it's important to have a standard procedure. Okay. Now there's an actual list. Okay, so it's usually helpful to display this in front of the client, in front of our water utilities, because they usually grab this list, and then in the next meeting they are identifying these pipes from this list and start making questions. Okay, so why is this pipe that has never been inspected or has an inspection class of 1, why is this pipe very critical? And we really like when they start asking questions, right? Because we are not a black box, so our model is explained by key variables, and if age is in place, or in the highlighted pipe, it's a very old pipe with a given material. So it's important that everybody using the software knows why the pipes have their criticality, what is the rationale behind these predictions. Okay, so we really strive to make people understand what they are doing. Okay, then the next question is, how good is this model? Okay, so is it really worth to use AI in this particular case? Okay, so let's see, this table here shows a summary of the inspected length per material. Okay, so as I said before, 68% of the network has already been inspected. Okay, and the utility was able to find roughly 20% of critical pipes. Okay, so how does the AI model behave? Let's see. So when guided by the software, just by prioritizing the first 5 miles, the success rate was already 35%. Okay, so for the whole network using Baseform, represented in terms of cost a 65% cost reduction. Okay, so just to summarize, this inspection app here derives a very objective result, which is the list of pipes to inspect in the next inspection program to get better results, or at least reduce costs, keeping the same success rate, right? So in this case, the utility opted by keeping the costs, keeping the success rate at a very impressive cost reduction. Okay, now this is the main usage of this app. However, some utilities want to use the information from this app to create renewal plans for wastewater systems using cost and risk dimensions. This is also possible on Baseform. Okay. Now I've talked about the prediction side using the inspections, but if I have some more minutes, I would like to take you to the monitor part of it. Okay, so a typical wastewater utility has not only results in terms of CCTV inspection, but may also have results on monitored flows. Okay, and they're extremely useful to identify areas with higher inflows and infiltration. Okay, so Baseform reconciles SCADA data from utilities to predict human consumption, and in this chart here, the shaded blue area around the metered consumption refers to an intelligent prediction of behavior that is used to identify outliers, which are the ones depicted with the red dots. Okay, in this case, the red dots are due to a rainfall event that you see on the top. Okay, so it rained and there's inflow and infiltration coming in. to the network. And this event in particular, and all the other ones, can be removed from the series to drive more accurate network modeling, event detection, quantify and control inflows and infiltration, and answer network capacity issues. Okay, so I think it's important to give you the full picture. Okay, so how do these things come all together? Inspections, flows, all the data that the utilities use, how do they come together to make more informed decisions? Okay, and I couldn't leave without showing you the 3D app. Okay, so this here is where all the information from the previous apps, monitor, prediction, could be others, so the key performance indicators from the previous apps come together, reconcile together to help the decision makers identify the most critical areas for intervention. Okay, so this is the same utilities. This is a full utility from the inspections example that I showed before. And they were looking for identifying the critical sewers faster and home in on problem areas. They also wanted to help in quantifying and locating infiltration and inflows. So the areas here are now showing the results that we got from the structural condition predictions. Okay, so the areas or the basins in red are the most critical ones in terms of predicted sewer pipes for inspections, and we are using, of course, GIS data, inspections data, inventory. We could also be using work orders if you wanted to identify SSOs. Okay, and then we are also taking the monitor data that I've shown you before. So the infiltration and inflows are also being considered here. And so it's very easy for a utility to identify the critical areas for intervention using both sets of indicators. Okay, so this is just to give you a very, very quick tour on the big picture that we are trying to talk about a little bit today. Okay. Now, I just wanted to, as a final remark, to say that water utilities continue to strive and maximize service quality and efficiency. So the goals are always the same: is to maximize service quality and efficiency. And from time to time, we end up with some keywords, futuristic keywords such as water 4.0 or digital water or digital twins. Now it's AI. And sometimes because these keywords lack a clear definition and actionable results, they end up fading away, and the water utility managers end up being very suspicious about innovation. Okay, so the main purpose of this presentation here is to tell you that yes, artificial intelligence and its application into the water industry is a reality, and we Baseform have been using it since 2015. So we want to demystify the concept this is very academic or scientific or no, this is really used by the utilities that you see here on the map every day. So just wanted to to make this very, very clear. Okay. And last but not least, here, well, yes, we are in Portugal, very proudly Portuguese, but we have partners all over the world. Okay, so thank you. This is what I wanted to cover today. I hope these thoughts can contribute to the discussion, and I look forward to any questions or comments. Thank you.
Thanks a lot, Aisha. Thank you for the presentation.
Yeah.
Okay, there is a question in the chat regarding the observed and predicted pipes. You mentioned, why are there color changes?
Okay. Yeah. So first, the colors would be either gray or, well, let me just, maybe I can just share back.
Yeah, I think the question was also why some previously inspected pipes change color with the prediction. Do you override the results of the inspection with the prediction?
Oh no, I think it's just the legend that is different. But let me just share here very quickly. Okay. Okay. So here, so in here we are showing the grays have never been inspected, and it's the colors. The color scale is from green to red. So the critical ones are in pink and in red. And in the next one, they end up with a critical length. Okay, so we can identify for each pipe what is the percentage of critical length in each pipe for the model. Okay, so that's the
Okay.
prediction coming in. So what is the percentage of criticality? What is the probability of that pipe being critical? Okay.
Okay, thank you. Maybe a next question is related to AI or the machine learning approach you are using. So as you say, there is no assumption in the model, meaning the model is learning from the data.
Exactly.
So do you sometimes have issues with extrapolation in the future? If you see only young pipes, how will you predict the evolution over time of these pipes, since you never observed all pipes?
Yeah. Here we really need to rely on a very good experience looking at the data, okay? Because this model really has that disadvantage. So we need to be careful. I mean, with this inspection analysis, it's always like a poll, okay? So it's like a poll before the elections. If you want to see to try to predict which candidate will win the elections, you need to make sure that your sample will mimify or will have a good representation of your network. So it's the same here. So you need to make sure that you try to have a little bit of each in the in your inspections data. Another way of looking at it is with Baseform's big data. So we tend to collect and to have lots of data that help us identify what makes sense, what and what doesn't. So there's also that side.
Multiplied by the inspection cost, or how did you assess that? And did you
Yeah.
verify that also with utilities that implemented the program?
Yeah. So this is something that the utility actually calculated, but essentially they were having a defined success rate. They were spending $40 per linear foot in their inspections. Okay, and they wanted to set a defined. They wanted to keep a defined rate of success and while reducing their costs. Okay, so that's how we established that success rate and then calculated back in order to have those cost reductions. Yes.
Okay, thanks a lot. And maybe a very last questions before we close. Where do you see the potential of AI in the Baseform suite in the next years? I mean, are you going to improve this tool, or do you see other new applications that do not exist now? What's your vision related to AI in these tools?
Yeah, that's a very good point. I guess AI is well a reality in the utilities that are using Baseform. This is really something that we are using, but this is a method, right? We are just trying to use a better method, right, to get better results and better decisions. From our experience, other things may also contribute and are not just the methods. Okay, so we tend to see water utilities working in silos and not communicating. So Baseform, I see that Baseform in the future can be a communication link, a communication platform using AI for sure, but somewhere where all the data comes in. Okay, so all the data is integrated and everybody can see the results in the same way. This is already something that we experience, but I would say that this should be something that every utility starts doing, using Baseform or not. Really breaking silos, improving communication, and making sure that the decisions are very much informed. So we are not replacing pipes just because the history tells us, or just using the history of brakes, or just using the oldest pipes. We are using tools, AI tools, or good tools that make us do those informed decisions. But I would say it's pretty much around seeing the same results and communicating all together in the utilities, because it's one utility that we want to manage, right? So
Okay. Then thank you very much, Aisha. I think we have to close this breakout session. Thanks again to both speakers, Aisha Mamade and Lengemann from Berliner Wasserbetriebe. Thank you both. Thank you for participating, for the questions.